Hi everyone, welcome back to Dr. Tutor. Today we're continuing with our Unit 3 Chemistry and we're doing Topic 1, Properties of Acids and Bases. Before we get started, don't forget to like and subscribe for a good ATAR. So let's start off with acids. I will mostly be yapping about acids, but I will talk about bases a little bit at the end so that they don't feel left out. So acids. The main thing to know is that they act as proton donators. This is like one of the definitions that we're going to use for acids is proton donors. And if you don't know what a proton is, it's, proton, neutron, electron, physics stuff. If you don't know, don't even worry about it because you don't even really need to know. You just need to know that sometimes it's written as P+, and sometimes it is written as H+, because it's actually the same thing as a hydrogen ion. So every time you hear proton donor in chem, don't even worry about it. It's just the same thing as a hydrogen ion. Acids act as proton donors, which basically means that when they are in an aqueous solution, so a solution with water, they dissociate, which means break apart, into H+ ions. Then the other thing to know is that they can be classified depending on the number of protons that they donate. If you have a monoprotic acid, mono means one, and protic means like proton related. And so monoprotic, as you can guess, means that they donate one proton. And you can also have polyprotic, which poly, meaning many, like polygon, or like polymer. Polyprotic, again, pretty guessable, means that they donate many protons. Within polyprotic, you can have diprotic, which means that they donate 2 protons, or you can have triprotic, which means that they donate 3 protons. But you don't really need to worry about those because they're not technically in the syllabus. So I would just remember monoprotic and polyprotic. And hopefully that's pretty easy to remember. Okay, so the next thing that we're going to talk about is the properties, right? That's the main thing that we need to worry about today. And those properties, we're going to talk about them specifically in terms of how they're related to the strength of an acid or a base. So firstly, let's talk about what actually is strength, right? Strength refers to basically how good an acid or a base is at dissociating into these ions. So we've just talked about how acid likes to donate protons, which means the same thing as it likes to dissociate into H+ ions, right? So strength is kind of equal to the level of dissociation. Dissociation, again, means like breaking apart, and it's into H+ or OH- ions. So mostly I'm going to talk about acids. Bases do the same stuff, exactly the same stuff, except they dissociate into OH- instead. So basically everything I say is the same for bases, but instead it's OH-. So yeah, so what is this like, what do I mean by level of dissociation, right? Let's draw a little diagram. So let's say this is our strong acid, and this is our weak acid. What we will see is that, like, say we have our solution in here, right, aqueous solution. Say we have 5 acid molecules in here, and we also have 5 acid molecules in here. In a strong acid, we would have our protons, or our hydrogen ions, attached to our acid when we add it in. So for example, if you have like HCl, the H is the hydrogen ion, and then when it dissociates, it turns into H+ and Cl-, okay? And that's pretty much how acids work. Like they'll usually have a H at the start, and then when they dissociate, it'll turn into a H+, and then a whatever minus. So we see that in a strong acid, out of these 5 molecules, 4, or maybe even 5 of them would like dissociate away. Maybe even 5, right? But in a weak acid, not that many would do it. These ones would all be stuck together. Maybe one of them dissociates away. Maybe 2 of them. But it's way less than the strong acid. So the way that we can kind of describe that is the degree of ionization. And what that means is like the degree as in like the amount, and ionization meaning it turning into ions. So we can describe it as dissociation, we can describe it as strength, we can describe it as degree of ionization. But what it basically means is when I put in a molecule of acid into an aqueous solution, what is the chance that it's going to dissociate? Or what is the chance that it's going to make a H+ ion? And if that chance is really high, like we see in the strong acid, then I can call it a strong acid, and I can say that my concentration of H+ is pretty high, whereas in a weak one, my concentration of H+ is probably much lower. Something to note is that strength isn't the same thing as concentration. Say if we add 10 more dots into here, and of that 10 more dots, or even like heaps more dots, right? And when I say dots, I mean molecules. Say I'm adding in like a bajillion more molecules. At this point, even if most of them haven't dissociated, probably I would still have like maybe 9 or something that have dissociated, right? So it would be like about 1/5 or 2/5 of the molecules would have dissociated, but that would still be quite a lot. It would probably be more than this one, because this one, let's say, has 5 H+. This one maybe has like 10 H pluses now, just because I've added so many molecules in total. But we don't say that this is now a strong one. It's still a weak one, it's just more concentrated. And so even though now the concentration of H plus might be greater, strength isn't the only thing that affects the concentration of H plus, the actual concentration of the acid also affects it. So just remember, directly measuring the concentration of H plus alone doesn't tell you the strength of the acid. You also have to consider the concentration as well. So concentration is the number of acid molecules that are in the solution, whereas the strength is how good they are at dissociating, or how badly they want to dissociate, or what is the likelihood that each one of those molecules will dissociate. Again, this is the same exact thing for bases, it's just that instead of H+, we're just talking about OH-. Alright, next property we're going to talk about is the quote-unquote reaction with water. And this is where we kind of start caring about like this thing, because when we have a strong acid, and we say that it's reacting with water, then let's write it as this, so HA, H being our H+, and A being like our A-. So like if we have HCl, then A would be our Cl. What we'll do, we'll add water. Sorry, I'm not including my state symbols. Sorry, chemistry teachers. And we would do this, and then we would get H+, plus A-, plus H2O still. This is all aqueous, by the way. Well, the water's liquid, I guess. On the other hand, if we had a weak acid, then it would be exactly the same thing, except we would have an equilibrium arrow instead. So the reason for that is because when we have a strong acid, we can say that, like, since most of these molecules are going to get turned into this anyway, it's kind of like just going like this, right? Because the vast majority of these molecules are going to be dissociating. However, when we have a weak acid, because they don't really want to dissociate, they don't really like dissociating, some of them are dissociated, some of them aren't dissociated, we can represent that with an equilibrium arrow, which basically is indicating that, like, yeah, some of them are like this, but some of them are like this. Again, same exact thing with bases. I'm going to bring up something here where I'll just write it like this, so, but a weak one is represented with an equilibrium arrow, okay? Something else that we can talk about here is, why do I have a H2O on both sides? Doesn't that look kind of messy? Yeah, it does, and chemistry, like, the CEO of chemistry didn't like that, so she said, let's just make up a new molecule called H3O+. And literally all that is that it's just so that we can, like, balance the equation and make it look better, but this is literally just the same thing as a H+ ion. I wouldn't worry about it. It's technically called a hydronium ion, but it's like, it's not that deep. Just allow it. Just let it slide. The final thing that we need to talk about, the final property, is conductivity. And conductivity is basically related to how good something is at conducting, like, electricity or heat. And when we say conducting electricity, electricity is just the flow of electrons. That's why it's called, like, electrons. And so when something is good at conducting those electrons, it usually has charge of its own. So the more charged something is, the more conductive it's going to be. So for example, salt water is a good conductor, and that's because of the fact that it has so many salt ions in it. Those ions are charged, therefore it is very conductive. However, like, normal water with no ions in it would be, like, way less conductive because it doesn't have any ions. In this case, when you have an acid, if it's a really strong acid, then that means that you're going to have a good conductivity, because strong acid will give you lots of ions because it dissociates a lot, and that means it's going to be good at conducting things. A weak acid is going to be bad at conducting things because it's weak, so it doesn't give you that many ions, so it's not that conductive. That's pretty much it. Just to quickly cover bases, it's all exactly the same thing for bases, except this is just like OH- instead. So a strong base will dissociate into a lot of OH- ions, a weak base won't dissociate into that many OH- ions. Again, strength is not the same thing as concentration, it's exactly the same stuff. Reaction with water, again, we would describe it the same way, except instead of HA, we would have like B or H, and then this would be like OH- and B+. Conductivity, exactly the same, so if it's a strong base, then you'll get good conductivity because you'll have lots of OH- ions, and if it's a weak base, you'll have bad conductivity because there's not that many OH- ions. So that's it for properties of acids and bases. If you want a full subject guide, you can find that in the link in description, or you can buy a active ATAR membership, which will give you access to all of our educational content for all of the subjects, as well as thousands of practice questions and answer explanations. Online tutoring and assignment help is also available on that link. As always, don't forget to like, comment, and subscribe, and send this to your friends if you love them and you want them to pass chemistry. Thank you. Bye.